Good evening, everyone. Thank you for joining us today. This is one of our first new events with our new event format of looking at projects of interest within the facade engineering fraternity. As some of you know, I'm heading up events at the SFE and also going to be taking part in this presentation, but the bulk of it will be going to our two other stars here. So I'd like to say a big thank you to Nick and to Matteo from Arup. Nick Jackson, director at Arup Architecture, and Matteo's a senior facade engineer at Arup Facades. So thank you very much to them. So the format will be that this is a fantastic project. It's a British land project that Arup obviously involved with and delivered by Lend-Lease. This really follows on from the sustainability last presentation we did about, how are we achieving sustainable buildings? And this one, has just been completed, but it's got a lovely story on how through some marginal gains and clever engineering, we could really add to the sustainability criteria for the project. So, gents, I think really I would ask if everyone obviously keeps their mics off. We are recording this. I will, if people could just add in any questions they have on the chat, and then we'll answer questions at the end, if that's okay. Yeah. Great. With no further ado, I'll hand over to you both, if I may.
Okay. Thank you, Nisha. And thank you very much for the opportunity to talk about One Triton Square. The image you see here is a CGI that was prepared probably about 2 years ago, I guess now. And we have just achieved practical completion on the building, and we're almost at the point you can see this in reality once the external works is completed. So maybe Matteo, if you could click onto the next scheme. So before talking about Triton specifically, it's just from our perspective at Arup, this is a sort of, it's a stop on a journey that began a long time ago, 10, 11 years ago, and probably earlier than that, with sort of first pieces of work we did around looking at circular economy and thinking through around building reuse and how you can reuse parts of buildings. And projects on this diagram really are just a whole series of projects that each in their own right looked at maybe one or two aspects of this. But what we feel we've achieved at Triton is we've brought together a whole series of pieces of work into one building, and it's the combination of those efforts really and measures that have achieved an overall performance step change that we think is really interesting. It's pretty mind-boggling, but in some respects, and sets a really good measure for people looking forward for the industry in terms of trying to reduce the total sort of carbon impact of projects. So next slide, please. And that's alongside that was work we've done in a number of areas around trying to look at what circular economy means in the context of buildings and projects of this nature, really. And that's in a sort of very holistic point of view. And I think one of the key things from this project is that it was delivered through the commitment of British Land and Lend-Lease and Arup to work collectively to work with the whole industry and supply chain and subcontractors and everybody to achieve this. And that wouldn't have been possible without that partnership. So next slide. The work around sustainable development, we based a lot of our thinking in Arup around the UN's sustainable development goals, and sort of aligning a lot of our thinking and work on development projects and property in particular around some of those themes that are most relevant. Next slide. And alongside that is really trying to shift the dial in terms of thinking about going beyond sustainability and simply, what we were doing maybe 5 or 10 years ago around sort of trying to design green buildings, into really looking at where we get to in terms of trying to design buildings that are either very low impact, zero impact, or starting to move towards, positive impacts, really. Triton is on that journey and is in a very good place on that, but we see there's still a long way, as we all know, to go on that before we're at a sort of truly regenerative sort of approach to how we do development. Next slide. So the sort of summation of this really, and it really is this simple, is it's all about the carbon. The work we've done over the last sort of 2.5, 3 years in analysing this design and developing and looking at the way we calibrate it, we estimate or have calculated fairly accurately that we're saving something like 40,000 tonnes of CO2 emissions over the 20 years of the first lease of the building. The building has been let, as I'll explain in a minute, on a 20-year lease. And that's when compared against either a new build REEB building of a good standard, or British Land's business as usual sort of new build. It's in that orbit, and you can calculate 40,000 tons of carbon in all sorts of ways, but one of them is just in terms of distances and normal cargoes. It's a pretty mind-boggling figure from that point of view. So next. So we'll come on to where those carbon savings are made as we go through this presentation. But just to sort of set the scene, so Triton Square was one of the biggest West End pre-lets in the last 2 decades. We set off on a journey of targeting BREEAM Excellent, but along the way we realized we could do better than that and collectively committed to trying to achieve BREEAM Outstanding. It's a 500,000 square foot building gross. The 40,000 tons of carbon that we think we've saved or calculated we've saved is split between embodied and operational. But it's the measure of the embodied carbon saving that is starting to, I think, to be really interesting in this. As the electrical supply, the grid decarbonizes through the increasing use of sort of wind and solar and green energy, the impact of embodied carbon on the overall carbon impact of buildings is increasing, and increasingly we need to look into that to really try and reduce it across all the sort of work we do. So Triton Square is located in, for those who don't know, on the Euston Road. It's sort of pretty close to the centre of the Knowledge Quarter, as it's known now, between the sort of British Library, UCL. You've got the Crick, obviously King's Cross, and developments going on at places like British Library that are all sort of building on that science, bioscience sort of world. Regent's Place is a long-standing campus of British Lands. And One Triton Square was originally developed in the mid-90s. It was an Arup Associates design. It was originally built for use by a bank. So next slide. And the story really we're going to take you through is whilst there are some significant measures we took in certain places, the overall story in terms of carbon and energy saving is a whole series of small measures, and bringing those together to look at what can be achieved by a number of interventions that, when seen collectively, make a big impact on the total impact of the building and the carbon saving. And the lesson is sort of, the easy analogy is to look at sort of, that world of high performance sport, whether it's rowing or cycling, it's very well understood story in those environments of high performance. So on Triton, this slide sort of illustrates some of the places where we've made those changes. There are obviously things like we kept the majority of the structural frame, we kept a lot of steel and concrete, which we'll come on to, but we also did significant things such as retaining, refurbishing, removing and replacing large areas of the original facade. And that's the story we're going to go through today in detail. Alongside that, we did things like we redefined the thermal line, we changed the MEP systems to have much more efficient MEP systems, whilst retaining some of the primary principles of the MEP design of the building. And we worked through other areas in terms of boilers, waste, and the sort of energy impact of ventilation systems and so on. Next slide. So this was the original building, ground plus 4 stories, built as a trading building, had cores on the corner, had this very deep recessive entrance facing off Triton Square, and these limestone clad cores. It had very good bones. It had very good floor to floor height, had a very good structural frame, that had high loading capacity because of the wish to be able to take the sort of dealing loads. It had good ventilation sort of infrastructure in terms of risers and voids. And interestingly enough, from the point of view of facades, had probably one of the earliest double skin facades that was built, I would say. So it had a single glazed outer skin. You see on the left there the horizontal tubes, which are the ventilation ducts for distributing the air into a displacement system in the floor. And then it had a double glazed inner layer with an interstitial blind system. And that actually gave us opportunities in terms of how we could reuse it. The other point was it was obviously designed by Arup, so we had a lot of data and records. Scheldebau had done the original facade. They had also their own records. We had all the shop drawings of that. So, you know, the parties involved in the original building were still there in order to pick up the original design and analysis and go on with that. So next slide. The original building, here we have the sort of 4 cores, big central atrium. The brief obviously for us was to increase floor area, increase volume of the building to effectively, you know, make it viable as a major refurbishment and reuse. The tenant was coming from somewhere else on the estate and was looking for a greater area. But you see it had this big empty atrium in the middle that was sort of letting light down onto the dealer floor that actually never happened. So next slide. So the original concept square plan with the corner cores and this sort of idea of proportion on the facade that went from the overall building right the way through to one of the panels of the elevation. So it's sort of, you know, it's very of its time in terms of this sort of very rational geometric approach. Next slide. So in a way, what we did in redesigning it was a sort of recalibration. You know, by the time come back 20 years later, Regent's Place has grown, Brock Street has been built, the surrounding buildings have established a sort of higher horizon, as you see also south of the Euston Road. And so we went forward with a proposal of adding 3 stories to the building that gives it a much better urban presence, building the cores up to sort of reinforce that. The upper stories are set back to create fantastic terraces, which are great for sort of well-being and for the occupier of the building. And we slid the outer skin, the cladding that we've retained, those 4 stories have been slid up 1 story, which sort of gives the base a much more generous sense and allows the building to interact with the ground plane much more successfully. And then the last piece on that bottom right corner is we completely reconfigured the corner facing Triton Square itself and the entrance to give it much more prominence, to make it engage with the square and actually just work architecturally much better than the rather deep recessive dark entrance that the building had. So next slide. So this is the floor plate as you see it now with a slightly reduced atrium. So this was all infilled with new steel structure. Cores kept the same, but that bottom right corner reconfigured in terms of entrance and increasing lifting and various issues like that. So next slide. So what you'll see is we achieved not quite doubling, it's about a sort of 85% uplift in net floor area for the client. And we did this without increasing the basement space or without increasing the plant area. So plant was reconfigured, worked more efficiently. We took advantage of some of the space provisions in the original building for sort of increases of plant that maybe hadn't happened. And we created these fantastic green terraces at 6th floor that sort of now look out over buildings down to either Regent's Park up to the northwest or Triton Square and Bloomsbury to the south and east. Next slide. And this drawing very nicely captures the sort of spirit of the building and trying to bring life really back into the heart of the building by animating that reconfigured atrium, connecting it to the entrance in the bottom of the drawing with escalators down to this very beautiful, generous double height entrance space. Then you slide up the escalators into an atrium sitting in the middle. And then what we've annotated on this drawing, which is probably a little bit small to read everything on here, but is all the sort of measures that have gone into the building to redefine and improve the performance of it, either from an energy point of view, from an operational point of view, or from reducing the embodied carbon. So next slide. And this just illustrates this sort of threading together of the old structure, which is the brown, the concrete structure of the original building, the cores that we've extended up that were steel and were retained, and then the new structure, which is dropped on top. There's a different story from today to tell you all about in terms of structural strengthening, rethinking the way the MEP systems worked, as well as working through, how those cores worked within the same footprint, yet to serve a much bigger building. And the sort of measures we were doing, we changed the way the foundation system worked from a sort of piled system to mobilizing the existing raft there and creating a sort of piled raft. We used carbon fiber to strengthen quite a lot of the structure, as well as other measures to strengthen structure to take the increased load. And we had the amazing story around the facade. So at that point, that gives you the overview of the project. I'm going to hand over to Matteo, who's now going to take you through the story of the work we did on the elevations.
Thank you very much, Nick. Thanks for this great presentation. So today, I would like to go through the Arup design drivers for One Triton Square. I will explain and show which are the main facade types, including which areas of the building have been reused and refurbished, and which cladding type has been designed and installed as new. Then I will deep dive into 4 of the main cladding system for this building before concluding. So One Triton Square is an exemplar project where a new facade approach has been validated, which is the reuse of the existing facade as opposed to demolish and rebuild. And this was possible mainly because the original Arup design was a design for disassembly. So on this project, around 120,000 of component has been dismantled and then reassembled on site for an overall extent of 3,000 meters square of facade. The next item is sustainability. So the team Triton for this project achieved and delivered the first circular facade, where big cladding panels have been removed, shipped to pop-up factory in Essex, where have been cleaned and repaired as required, and then installed back to the main cladding, to the main building. In terms of performance, the 1990s facade, the double-skinned facade that was originally designed by Arup, is one of the main features of this building, and the pioneering approach to design that Arup had 30 years ago allowed the design team and the client to take key decisions on this project. This is a nice comparison between what was designed, and it was a visual on the left, and on the right you can see a site picture that I took during one of my site visits. So Arup designed the original building in 1990s, and in around 2015, British Land, the client, asked us to redevelop the building with the addition of 120,000 square foot of flexible office space. One of the important, on the key aspect of this project, and it was fundamental for the success of One Triton Square, was that Arup, the Arup team had the access to all the design information of the original building, as well as built drawing from the original facade contractor, which was Schädelbau. And the review of the existing drawing, understanding how they were put together, their performance and the specification, allowed the Arup team to identify key opportunities to this project. And those opportunities were identified in the reuse of the existing external screen of the double glazing unit, as well the reuse of the stone panel around the core up to level 5, the reuse and the refurbish of the strip window at the core, as well as the granite panel at the ground floor. Everything else was designed and built as a new cladding Some of them are unitized curtain wall system, some with stone, some with vision glazing, some other are stick curtain wall system, especially at the ground floor. So as you can understand, this is a extremely complex project, and during the design phases, we have individuated around 25 facade types between main cladding type and subtypes, and this and the complexity, and we had to prepare a digital model of the system of the entire building, which was used to map out the main cladding system in terms of the cladding type, material, and whether they had to be reused or designed as new. The existing double screen facade is the main cladding type, is the main system for this project, is the most interesting part of this development. So originally, the system was composed by an outer monolithic glass, which is fixed to a 3-meter wide times a story high unitized module, which is hung at the top and restrained at the bottom. The inner skin was composed by a double glazed ribbon window installed into a strong back system. In between the inner and the outer layer, there was a 1-meter grid ventilated where the mechanical system are running. So this is a detail from Schädelbau, where you can see how the system works, how the original system works. There is the outer screen fixed back through a galvanized steel bracket to the slab. The only element that is replaced as new for this facade type is the ribbon window highlighted in yellow. So the access to this information allow the Arup team to investigate opportunities for this project, and we have outlined a strategy to dismantle the external screen and installing back to site. So Arup experience and expertise in defining which element should have been kept, and in particular the glass and the frame, and which components were at the end of the design life, such as gasket and seals, was one of the key elements during the design stage. So not only the external screen was removed, shipped to a pop-up factory in Essex, where it was cleaned and repaired, but and then it was shipped back and installed on the main building. Not only it was installed back on the main building, but it was installed 1 story up the original position, as this diagram is showing. And one of the main reasons for doing that, it was due to the fact that we wanted to maximize the daylight of the ground floor and the first floor spaces, as shown in this diagram. So all the panel, after being refurbished, have been shipped back to site and installed back to the position. And another interesting thing is that the original facade that was designed in 1990s is still meeting the energy and the sustainability target. So this is an important aspect of this project, because it outlined that refurbishment with reused cladding still can meet the one of the highest rating. In fact, this project is achieving BREEAM Outstanding. And why this still meet the target is because the pioneering approach of Arup still work. So the outer screen modulates the solar gain through the first layer, whereas the double glazing unit, which was installed as new, fully insulate the building. So all the cladding above level 6 were designed as a new cladding system, and following the original design, all the cladding types have been above that level were designed as a unitized curtain wall system, with particular attention to the energy aspect. So in fact, as you can see, the original detail include the setback in the facade and the horizontal and vertical shading system to screen the solar radiation. Another special cladding type is the stone cladding, and this markup shows the extent of the stone facades. So you see with the color on the elevation is homogeneous throughout all the facade. The system at the back is different. The dark blue area at the bottom represent a handset stone fixed back to an existing precast panel, whereas the light blue areas at the top are new, have been designed by Arup as a new stone cladding fixed back to a unitized curtain wall system that has been designed and built by Permastilisa UK and Gardner, and then installed back to the building progressively from the bottom to the top. One of the incredible thing is that, as you can see from this picture, is that the color of the stone panel matches between the new and existing, and this is extremely difficult to identify what was the line between the new and the existing one. And this was possible because Arup had the access to all the design information. We knew what was the original quarry where the stone has been originally taken from, and the stone cladding panel have been removed from the Triton Square. They were clean, and then compare against the new limestone. The new stone and the original stone is a French limestone, and all the panel have been visually tested against the original building. Another interesting system is the unitized cladding system with the GRC features above the main entrance. This facade is exposed to southeast, so the original design by Arup included important vertical and horizontal external shading system to modulate and screen the solar radiation. The new facade were designed as a unitized cladding panel, fully disassembled with additional add-on element. And this system was visually tested against a visual mock-up. It was then fully off-site tested at Gardner facilities, and then shipped to site and installed as a unitized module on the building. The last cladding type is the Atrium roof light. So the original Atrium roof light was 25 meter of diameters, and throughout the design stages, we realized that Arup realized that it was not necessary to have so big roof light, and therefore it has been reduced to 18 meters. And that was mainly to increase the office floor plate and to increase the office floor plate. So to respond to that, Arup undertook extensive daylighting studies and glare analysis to determine the impact on the office spaces. As well, we did a structural calculation to understand to minimize the amount of steel and the depth of those portal frame, which spans more than 18 meters. System design drawing were also necessary to understand which were the tolerances for this project in order to accommodate the 3x3 double glazing unit. The roof light was designed, fabricated, and installed by OAG facades. And the roof light was also off-site tested and then on-site host tested to determine and to check that the system is fully watertight. So overall, 40,000 tons of carbon were saved, and this is the equivalent to the annual energy consumption in 10,000 homes. So we can say that Arup saved more carbon in the design than it will be produced in operation for the next 40 years. And as you can see from this pie chart, the contribution from the facade to the overall carbon is quite substantial and is almost a quarter of the total. And the campaign of marginal gain also consider every contribution that the facade made, in particular the circular facade approach, the retention of the strip window, the retention of the limestone cladding, as well as the high performance facade design and the reduction of embodied carbon in service. So as I mentioned, and we as Arup, we did an extensive embodied carbon calculation to determine what is the impact of our design against the sustainability target. And as you can see from this table, the envelope, the embodied carbon reduction of the envelope has been estimated around 3,700 tons of CO2 emission, which is 1/5 when compared against what has been the carbon emission for the superstructure and the substructure. So concluding, I want to give you some observation, and the first one is that the design for this assembly is one of the key aspects, and the original Arup design that was made in 1990s was one of the key aspects that unlock and enable the design team to validate reuse opportunity, as well as the Arup experience in identifying which cladding component were at the end of their life and which cladding component could have been kept. The next item is performance. So the 90s pioneering double skin facade that was designed at that time allowed the reuse of the outer screen, and overall this system, which is a 30 years old system, is still meeting the energy target and contributed to achieve the BREEAM outstanding. The last item is sustainability. So overall, we need to consider the whole life carbon as an industry when we design, but also as we test our solution against cost. I think we need to test also the design against embodied carbon and compare against the targets. And I think that the last item, the last element for a successful RECIP is having a great team of like-minded collaborators from British Land Lease, Arup, as well as all facade contractor, Gardner, Permasteelise, and OAG. Thank you very much.
Matteo and Nick, thank you so much. That was fascinating. I'm just going to round up with some little snippets that I found from the Lend-Lease team. Unfortunately, Chris Carrier and Steve Brown couldn't join us today. They were heavily involved. And Richard Press from the Lend-Lease facade team also gave me some interesting snippets. So just a few little ones to round up some of the challenges that ourselves in delivering the project with the facade contractor had. So I think a very positive thing, I know Nick and Matteo picked up on this, but things like originally they were going to send the profiles back to Germany to be refurbished, and they agreed they would be done in the UK. So again, really helpful gain there. One interesting thing was talking to the contractor, Michelle Debau, who did it originally. One of the more seasoned members that had said to them, and this will make you giggle, thought that it had to be removed from left to right. When they actually came to take it off, it actually needed to be moved from right to left, and apparently that did cause quite a problem. A site challenge, very much so, was fascinating that moving the facade up one level, and I think it wasn't until it was actually came to be putting it back on that they appreciated that actually the brackets all needed to be moved up as well, and that meant that they then had to wait until the 6th floor was finished to actually move the brackets from 5th up to 6th, and that again was another big challenge. A great fact here, apparently there were 30 tennis courts worth of facade that were removed and put back on, and that involved 130,000 components. So I think it really does show that, you know, we've all seen how sustainability is really building up momentum at the moment, and it shows that with a lot of, you know, some sensible thought, clever thought, you know, these guys have already shown that it can be done. So I'd like to say thank you very much. Fascinating presentation. On that, I'm now going to basically take some questions. So let me just whiz up to the chat. So good evening, Mr. Aspinall. Thank you for your question, which was, could the aluminium sections of the inner skin not have been used with new gaskets and IGUs? I don't know, Matteo or Nick, if either of you could answer that.
So I can go with it, Nick. So I think that one of the, so in this case for this project, the inner screen of the facade was decided to be replaced as new because it was after 20 years of design life. We recommended to replace it as new. Because also the sealant and the gasket were at the end of their design life, and that portion of the facade was one of the key element to maintain the water tightness and insulation and air tightness of the system. So it had to be reinstalled as a new component.
I think the point was the aluminium, though, was just a very small carrier frame. It wasn't a big sort of mullion. They basically sat in a top and bottom channel. And I think the original carrier frame was bonded on. Matteo, wasn't that the case?
Yeah. I think if I'm not wrong, yeah, that was, yeah.
Yeah. So it was a very small, very light piece of aluminium that in the end it was as easy to get replaced and try and cut off and strip back and so on.
Sorry, I muted myself. I've got both my cats are meowing in the background, so I'm muting myself in between. A question from Gabrielle Pirazzini. Thank you, Gabrielle. Did you retain the glass of the outer facade? And did you consider using triple glass for further improvement, or was it too marginal?
Well, we retain the outer glass. It's the same piece of monolithic glass taken off, cleaned, remounted, and put back on. Matteo, I'm not sure we did look at going to triple for the inner skin, or whether that would have made any significant difference, given that we already had a double facade for that.
Yeah, no, so since we had already a double skin facade, a double glazing unit would have we perceived that was sufficient to achieve the its purpose.
Form.
Yeah.
Great, thank you. And the next question is from Fawad Jamuzi. Excuse me if I've not pronounced that correctly. Please let me know, do you have any challenges with regards to complying with the approved document B, specifically for reusing the existing materials?
So around the facade elements in terms of Part B, I don't think we don't have any. In terms of the glazing elements, there's no areas of sort of fire rated construction. There's obviously fire stopping and so on at floor edges and so on that was on the whole, I think retained but checked and made good. I don't think that was all stripped out, was it, Matteo?
So all the fire stop have been replaced as new.
Okay, sorry. There were areas of sort of substandard fire performance we found in some areas of the solid cores, and we had to go in, and there are areas there where we did have some quite significant challenges to go back and add additional material or re-engineer things. And yeah, in sort of broad design terms, no, it wasn't challenging, but actually the reality of actually unpicking the actual as-built condition presented plenty of detailed challenges at junctions and interfaces primarily around the cores and fire separation around compartments and things like that.
Thank you. There's one other question from Mr. Aspinall. It was very on the ball today. He was asking, was the outer monolithic toughened and heat soak tested in 1990? So
yes, the outer skin is monolithic toughened, and in terms of heat soak testing, I'm not sure if it was heat soak tested, but as far as I'm aware, none of the.
Interesting question. I suppose if
lasted 25 years.
I know. Yeah. I think if we were going to get into glass discussion, we'd be saying, well, if it was going to pop, it would have probably done it in the first 5-10 years, maybe.
Yeah.
But, yeah, a tricky one. But thank you, Chris. So I don't. Yeah, he said he'd be very surprised. Mr. Press, can you answer that? Do you know if it was heat soak tested?
I don't know either. No.
Okay.
Unlikely.
Yeah, unlikely. Thank you, John. But no, are there any other questions from anyone? It wasn't, no. Okay, so that's it wasn't apparently. But I think, like you said, it's what we do know of nickel sulfide. It tends to rear its ugly little head fairly early on. So, thank you. Any other questions, anybody? Well, in that case, I was going to say, Chris, I don't know if you want to sign off as chairman or you want me to finish off. Chris isn't saying anything. Okay, so as
hi, hello, Nisha.
Hi, Chris.
Hello, everybody, and you've taken me a bit by surprise there, Nisha. I was sitting here with a glass of wine in my hand, relaxing.
I thought I'd just catch you out.
Just to add my thanks on behalf of the SFE and all the members, and thank you very much indeed. Fantastic project, really, really interesting, and recycling of the facade, very similar to the work that you've been doing on the project in Broadgate recently with the cooled facade, which Gartner you designed back in the 1980s, which has just been recycled again, which is as Nisha said, a bit of momentum growing in this direction. So really interesting to see, thoroughly enjoyed it, and thank you very much for your time and your input, and for everybody who's joined on the conversation this evening. And I'll hand you back to Nisha.
Thank you very much. So again, gents, thank you so much for that. We have recorded the presentation, so I'm sure Jack will make that available for people who've, for the SFE members. I'd like to say please keep an eye out. We are arranging some more seminars coming up, and we look forward for you joining us then. And I'd say I think everyone deserves a little round of applause.